Okay, today we're going to wrap up chapter 6. I told you there were 2 additional things we needed to do from chapter 6. We've set up all the machinery in the sense that I explained the concept of how prices are set in the spot market, the concept of quoted prices and cash prices, and the concept of accrued interest. So let me write some of this stuff down. This is what we set up. In the spot market, and in the futures market. In the spot market, we have the concept of cash price is equal to the quoted price plus accrued interest. In the futures market, we had how futures prices are set. We had the cash futures price is equal to the quoted futures price times the conversion factor plus the accrued interest. So let's summarize the stuff we've done so far. First, I explained the concept of accrued interest, and I showed you how you can calculate it in 3 cases. In the case of treasury bonds, corporate bonds, and money market securities, where we had the idea of actual over actual, 30 over 360, and actual over 360. Then I showed you how to calculate the conversion factor. And there are 2 methods to calculate the conversion factor, depending on whether the bonds are type 1 and type 2. And whether they're type 1 and type 2 depends on when the next coupon payment is due. Whether it's due in the next, we know the next coupon payment is going to be somewhere between now and 6 months. And that's simply because coupon payments are paid 6 months apart. So, depending on whether the coupon payment is paid in the next 3 months or in months 4 through 6. If they're paid in the next 3 months, then we refer to them as type 1 bonds. And if the coupon payment is paid from 4 to 6 months, we refer to them as type 2 bonds. And I showed you how to calculate the conversion factor using a 10b2 calculator for type 1 and type 2 bonds. Okay? Then I explained the concept of cheapest to deliver. Cheapest to deliver. Okay, so when the person with the short position has the right to choose the bond, has the option to choose the bond to deliver. And they can choose any bond depending on on a range of maturities and coupon payment. Now, remember I told you we have 4 types of treasury bond futures contracts: the 2-year, 5-year, 10-year, and the T-bond contract. Each one of those contracts allows you to deliver a bond within some range of maturities. For example, the 2-year bond allows you to deliver a bond between 1 3/4 and 2 1/4 years to maturity. The 5-year bond allows you to deliver a bond between 4 2/3 to 5 1/4 years to maturity. The 10-year bond allows you to deliver a bond with 6 1/2 to 10 years to maturity. And the 30-year bond, or the T-bond contract, allows you to deliver bonds with maturity 15 to 25 years. So each contract allows you to deliver any bond within that range. Now, in addition, you have the flexibility. The person with the short position has the flexibility to choose the appropriate coupon payment. Okay. Now, each of these contracts, whether it's the 2-year, 5-year, 10-year, or the T-bond contract, they're all written on 6% coupon bonds. So we refer to that as the base case bond on which the contract is written. However, you can deliver any bond. Its coupon rate could be less or more than 6%, right? And depending on, if you deliver a bond that's exactly a 6% coupon payment, then the conversion factor of that bond is 1, because you're delivering a bond on the futures that's on which the contract is written. However, if you deliver a bond either above or below 6%, Then you have to calculate the conversion factor. And I told you what the conversion factor is defined as the quoted price of the X% coupon bond, whichever bond you deliver, divided by the quoted price of a 6% coupon bond. And I showed you how to calculate that ratio for type 1 and type 2 bonds. Now, I showed you how to do it with the 10B2 calculator, whereas the textbook does it slightly differently. It's extremely important to go back to my lecture and see how you do it using the 10B2 calculator. So we've done this and this. And then finally, the concept of cheapest to deliver. The concept of cheapest to deliver is you can deliver any bond in that bin of coupon payments and maturities. So the person with the short position will find out which is the cheapest bond to deliver. And by cheapest, what we mean by this, the person with the short position has to buy the bond on the spot market. So there's a cash outflow. So what the guy does is he buys the bond in the spot market, pays the cash price for that bond, right? And then he delivers the bond on the futures contract. When you deliver the bond, you get paid the cash futures price. So this represents the net cash outflow with respect to the person with the short position. And what this fellow wants to do is minimize that. Minimize the net cash outflow. And in the example I showed you last lecture, I think this was example 6.1, but it's in the text. There are 3 bonds in the bin that he could deliver, and he calculates the net cash outflow for each of these bonds, and the one that has the least cash outflow is the cheapest to deliver bond. So for those of you who are just practicing for the test to make sure you're well prepared, we've studied 3 types of problems. The first type of problem is how to calculate the accrued interest. The second type of problem, how you calculate the conversion factor. And the third type of problem was how you figure out the cheapest to deliver bond. Okay, now we're in a position to put all this together, right? And develop the arbitrage-free method by which quoted futures prices should be determined. Okay, now what I mean by that is this. Okay, what I'm going to do is I'm going to erase this idea of cheapest to deliver. You know what that is. I just need my board space. Okay, I'm going to stick with those 2 equations, right? And now we're going to determine how arbitrage-free futures prices are determined in the Treasury bond futures market. Now, this is in some sense a continuation of what we did in Chapter 5. For example, in Chapter 5, I studied 3 underlying asset classes. The first one was financial securities. That was equations 1 and 2. Remember the 6 equations I set up. Then we studied what was this? Currency futures in equation 3, and problems 4, 5, equations 4, 5, and 6 dealt with arbitrage-free futures prices where the underlying is a commodity. So the 3 asset classes are financial securities, currencies, and commodities. So what we're doing over here is taking this one step further, because what we're talking about over here are interest rate futures. Okay, so we have to figure out how we determine, or what is the relation between spot and futures prices for these interest rate futures contracts. That's what we're trying to determine. Okay, so when we look at these 2 equations, what we're trying to determine is this. We have, the important thing is, what do we have? What we observe in the spot market is the quoted price. Okay, so let me highlight that with a slightly different color. We have the quoted price over here. That's what we observe. And then also what we observe in the futures market is the quoted futures price of the base case bond, the 6% coupon bond. Okay, so what we observe is only 4 quoted futures prices, right? And these are on the 4 contracts, the 2-year, 5-year, 10-year, and the T-bond contract, all of which are written on the 6% coupon bond. Okay, so we observe 4 futures prices. That's what this refers to, the quoted futures price. Now, in the spot market, we have thousands of bonds, treasury bonds, right? And what we observe on the Bloomberg system, for example, are the quoted prices of all the bonds out there. So these two are observable, right? Those are the observables. Okay. Now we have to figure out, right, of all the prices in the spot market that we observe and the 4 futures prices we observe, how do we know that all these prices are arbitrage free? That's the question. You can see it's a little tricky. Unlike previously where we had the futures contract of the S&P 500, we had one price for the S&P 500 futures, and then we had one price for the S&P 500 in the spot market. Similarly, if we looked at copper futures, we had one price for copper in the spot market, and we had a price for copper in the futures market, right? And you could see whether the spot and futures prices were arbitrage free based on the 6 equations I showed you in chapter 5, right? So here it's a little tricky because what we observe is we observe 4 prices in the futures market. These are the base case bonds, all 6% coupon bonds, right? And then we observe several thousand or several hundred or close to 1,000 or more prices in the spot market. All these different bonds with different maturities, right? In the treasury bond market. And the question is, how do we know that these 4, right, are arbitrage free with respect to all those spot prices? That's tricky business. Okay, so in other words, what we're trying to do is this. We're trying to determine the arbitrage-free relationship between that, right? But we can't do it directly. We have to do it indirectly. What we have to do is, first, since we have these 2 equations and these are the observables, we can start with the first observable, quoted price, right? And from that, calculate the cash price because we know how to use equation 1. Let's call this equation 1. Let's call this equation 2. Okay. Then, this cash price in the spot market. Now, tying this back to chapter 5, right? The cash price in the spot market can be viewed as S0. That is the spot price, right? Because any bond that you buy in the spot market, you pay the cash price. And so the cash price can be denoted by S0, that is tying it to the notation we used for spot prices in chapter 5. Okay. So also the cash futures price, right, is the futures price when you deliver a bond. That's the price you receive. The guy with the short position delivers a bond, and that's the amount you receive. So in the notation in chapter 5, this is denoted by F0T. Okay? So what we have is, we take step 1 over here. I'll mark that as step 1. Then, once I have the spot price, I can calculate given the spot price, I can calculate the arbitrage-free futures prices using what we derived in the previous chapter. So, those of you who have your textbooks in front of you, you might be wondering what equation 6.1 on page 138 is. 6.1 on page 138 is this equation. F0T is equal to S0 minus I e to the RT. Remember this equation? This equation in chapter 5, this was chapter 5, this was my equation 2. My equation 2a. Remember I had the equations 1, 2a, 2b, 3, 4a, 4b, 5, 5a, 5b, and 6. This is from chapter 5, my equation 2a. Okay, it gives you the relation between the spot and futures prices for financial securities that pay a discrete dividend, right? So now, look at this equation and look at the framework that I'm setting up over here. Step 1, remember the green boxes are what I observe. They are the observables. So the first step is using that observable. I can use this equation 1 to infer S0. Once I know S0, I can use this equation in step 2. Step 2 over here, I can use this equation where I know the spot price to calculate the futures price. Because I know the spot price, I can calculate the futures price. Right? And then step 3 is, once I have the futures price, I can use equation 2 to infer, that's step 3, I can use that to infer the quoted futures price. So what I would like to know the arbitrage-free price between these two observable quantities, but I can't determine it directly. I have to do it indirectly in 3 steps. 1, 2, 3. First step, I get S0 using this equation. Second step, I get F0t using this equation. And third step, I get the quoted arbitrage-free quoted futures price, right, using this equation, where I know this, I know these two that I know how to calculate, and I infer this. So that's the 3-step approach to determine the arbitrage-free relation between these two quantities, the quoted price in the spot market and the quoted futures price in the futures market. Remember, we want the arbitrage-free relationship between those two quantities because those are the observable quantities. Okay, so how do we do this 3-step approach? This is illustrated in example 6.2 of the textbook. So let me pull that out and I'm going to read it. Reading example 6.2 on page 138. The first sentence is this. Suppose that in the Treasury bond futures contract, it is known that the cheapest to deliver bond will be a 12% coupon bond with a conversion factor of 1.6. Now, that's a very, let me put my book down. That's a very loaded statement because it's saying a number of things. It's saying that that the cheapest to deliver bond is a 12% coupon bond. In other words, remember, if we draw the timeline over here, this is 0, this is t, and this is t2. The timeline for these bonds are, at time 0, I get into the futures contract, and I agree to the futures price. At time t1, I buy the bond, and at time t2, the bond matures. So when we're trying to determine these arbitrage-free relationships, we're trying to determine the arbitrage-free relationship at time 0. That means when I agree to get into this futures contract at this futures price, how do I know that's a fair price? What I mean by a fair price means an arbitrage-free price. So how do I know it's a fair price at time 0? So you look at how the question starts. It starts by saying, suppose we know that the cheapest to deliver bond is a 12% coupon bond. Now, it gives you the conversion factor 1.6, but that's a side issue because if I give you a 12% coupon bond and the other attributes of the bond, You know how to calculate the conversion factor. These are the type 1, type 2 bonds in the textbook where I showed you how to calculate the conversion factor. So the second part is moot, right? Because you know how to calculate it even though it's given over here. But the first part, how do you know that the cheapest to deliver bond is the 12% coupon bond? That's the question, because you have to determine the arbitrage-free price over here. Whereas the guy with the short position will wait up to time T1 when the futures contract matures, then make a determination, right? Like the exercise in example 6.1 in the text that I showed you last lecture. Then the guy will do that calculation and determine what the cheapest to deliver bond. That means strictly, right? The only time you'll know for sure what the cheapest to deliver bond is at the maturity of the contract. So the question is, how do you know what the cheapest to deliver bond over here at 0 is going to be? Now, of course, the guy with the short position doesn't care. The guy with the long position who gets in this contract, right, is at a disadvantage. He doesn't know what the cheapest to deliver bond is going to be, right? So the guy with the long position has to anticipate what he thinks the cheapest to deliver bond will be, and then agree to a futures price as if that specific bond is going to be delivered, right? So for example, go back to my housing example I gave. Suppose you get into a contract to buy a house, right? And you write up the contract and you're trying to figure out what price to agree to the house. What you have to assume with each line item in your contract, right? The builder is going to deliver the cheapest stuff. He's going to deliver the cheapest faucet, the cheapest tiles, and the cheapest, crown molding. You have to assume that, right? And therefore, when you agree to the futures price, you will agree to what? You will agree to a price assuming that the builder is going to deliver each of these items in this category, the cheapest that they can find, okay? That means you agree up front, assuming that the cheapest to deliver is going to be delivered. So that's what the guy with the long position has to do at time 0. He has to anticipate what the cheapest to deliver will be, and then assume that is going to be delivered. And then ask himself at time 0, given that, is this the futures price I'm willing to pay? The futures price that I observe. Is that the futures price I'm willing to pay? So the guy with the long position has a tall order to satisfy. But it's not so bad. Because what the guy with the long position has to do is this. Remember I told you, we had this picture. Zero to 30, 0 to 12. And then we had our 4 contracts. 1, 2, 3, 4. Okay, so this is the maturity. This is the coupon. So remember I told you, the guy with the short position can deliver any bond in one of, if it's a 5-year, this corresponds to the 2-year, 5-year, 10-year, and the T-bond. So, say we're talking about the 10-year contract, right? The guy with the short position can deliver any bond in this bin. Okay? So you have to anticipate which bond is he going to deliver. Well, at time 0 in this timeline, at time 0, you have to anticipate, are interest rates going to go up or down? So the guy with the long position has to anticipate, are interest rates going to go up or down? If the interest rates if you're expecting interest rates to go up, let's call that up. Let's call this down. If you're expecting interest rates to go up, all bonds will go down. But which bond is going to go down the most? The one with the longest duration. And the longest duration bonds are located over here, in this part of the bin. Why? Because that's the longest maturity that you can choose and the shortest coupon payment. Okay? So if you expect interest rates to go up, you look for bonds in this bin and say, which one is the cheapest to deliver? The longest maturity and lowest coupon. That's the bond that you will assume will be delivered as the cheapest to deliver bond. If interest rates go down, so this is up. If interest rates go up, you'll pick a bond from that bin. If interest rates go down, all bonds go up in value, right? Then what happens, right? The guy with the short position will deliver the bond which has gone up the least. That's the one with the shortest duration. And which bond has the shortest duration? It has a combination of the shortest maturity and the highest coupon payment. That's from this corner of the bin. So I'll put D over there. So if you expect interest rates to go up, you'll expect the shortest to deliver bond would be from this area of the bin. If you expect interest rates to go down, the cheapest to deliver bond would be from that area of the bin. Of course, the guy with the long position has to still anticipate which way interest rates are going to go, up or down, right? Whereas the guy with the short position has the benefit of hindsight. He can wait up to maturity, see whether interest rates go up or down, and then decide which corner to go to. So the bottom line over here is the guy with the long position has an extra task to do, which is anticipate. So now you can see all the macroeconomic stuff I taught you, which is trying to anticipate which way interest rates are going to go, becomes very important, right? Because if the majority of people believe in the market that interest rates are going to go down, they think the cheapest to deliver bond will be over here. If you think interest rates are going to go up, the cheapest to deliver bond will be here. Now, if market prices of futures contracts are written assuming the cheapest to deliver bond is going to be picked from here, but you think the cheapest to deliver bond is going to be picked from here, is there an arbitrage opportunity for you? Or is there a trading strategy for you? And the answer is yes. Okay? So that's pretty sophisticated stuff. Now, coming back to this. So, coming back to reading the question. Okay, the first part of the question is, suppose that the Treasury bond futures contract, it is known that the cheapest to deliver bond is a 12% coupon bond at the conversion factor 1.6. So I explained that. The second sentence reads, suppose also that it is known that delivery will take place in 270 days. Well, that's not a complicated supposition. All that's saying is the maturity of the futures contract is 270 days. That's all. So that's not a complicated. Coupons are paid semi-annually. Okay, so let's continue reading this, and I'm going to set up the timeline for this problem. Okay, so this is 0. This is 270 days. Okay, so this is where you're standing currently. And the futures contract matures on that. Now, it says that the last coupon payment was paid 60 days ago. So there's a coupon payment over here. And what is the coupon payment? It's a 12% coupon bond. So there's a coupon payment over here of 6. And it says that the next coupon payment will be in 122 days. So let's put 122 days. There's another coupon payment of 6 over here. And then there's another coupon payment in 305 days. 305 days. And that's another coupon payment over here. Okay, so for convenience, what I'm going to do is to distinguish between which is which, I'm going to put this in red. Okay, in red, what that does is it tells me what are the parameters of the futures contract. Okay, we have, you're standing at time 0, and the futures contract matures at time 270, and on that timeline, the coupon payments of the last coupon payment of the bond, the next, and the following coupon payment. So the blue tells you what the coupon payments are. Okay. We also assume that the term structure of interest rates is flat at 10%. So we're assuming that the interest rate R, all maturities, is 10%. Okay, now it doesn't have to be 10%, right? It just makes it a little easier for us, because you know when you have different interest rates for different maturities, you know how to discount those different interest rates, assume those different cash flows at different interest rates. It's not a big deal. But over here, we don't want to add the added complexity of different interest rates at different maturities, because we're trying to solve a complicated problem to begin with. Okay, so let's not worry about let's keep the zero curve flat. Okay, then, so it says, reading the question, the term structure is flat at a continuously compounded rate of 10%. Now, assume that the quoted price is 115. So, what we land up over here is we assume that the quoted price over here is 115. Okay, so that's what we start out with. Now, on my timeline, remember what I've done. I've determined the first sentence in this question is an extremely important sentence, right? And it means hell of a lot. But we can't even draw this timeline until we know, or we can project what the cheapest to deliver bond is at time 0. That means this analysis precedes that. And then we discovered based on that the cheapest to deliver bond is going to be this 12% coupon bond with a conversion factor of 1.6. Strictly speaking, what it would be is you would project it to be suppose you expected interest rates to go down. This 12% coupon bond is a high coupon bond with a low maturity. So strictly in real life, what you would do is you would go to this bin and pick the bond with the highest coupon and shortest maturity. So you would have those two parameters, coupon and maturity, right? But once you know the coupon and maturity, I showed you how to calculate the conversion factor, right? So, and the conversion factor is given as 1.6. So notice the problem has has made that part of the problem simple in the sense that I've given you a 12% coupon bond and I've given you the conversion factor. But I'm trying to outline to you in practice, right, how you would get the coupon rate and the maturity from this analysis, and from the coupon rate and maturity, you would calculate the conversion factor. That's how you would get the conversion factor. But for now, it's given as 1.6. Okay, now, so we start out with this. Once I know the cheapest to deliver bond, notice this timeline of cash flows is written for what I anticipate will be the cheapest to deliver bond. Now, if I make a wrong assessment of what I anticipate to be the cheapest to deliver bond, what will my analysis give me? It'll give me another arbitrage. It'll be screwed up completely, and it'll give me an arbitrage-free price that'll be incorrect. And if I go and trade on the market, assuming that, I can get screwed royally. So let's continue anyway. So now I know the quoted price, right? And this timeline from the cheapest to deliver bond that I anticipate. That is the 12% coupon bond. Look at the 6 coupon payments over here. Okay, now I'm going to go through this 3-step process. Look, the quoted price, this is what I have, right? Now I have to calculate the cash price in step 1, this step 2, and this step 3. So I'm going to go through those 3 steps, step by step by step. Okay, the first one is, how do I get the cash price? The cash price is equal to the quoted price plus the accrued interest. What is the quoted price? It's given. 115. What is the accrued interest? Okay. Now notice I'm calculating, this is the cash price at time 0. This is the cash price at time 0. So what is the quoted price? The quoted price is, this is the quoted price. It's given as 1,115. So what is the cash price? For that I need the accrued interest. The accrued interest is given by what? The number of days since the last payment, which is 60, divided by the number of days between payments, which is 60 plus 122, times the coupon, 6. Okay, so if I look at what that value is, it's calculated in the textbook. It's given as 116.978. Okay, so I'm going to write that as step 1. So let me write this over here as step 1. Okay, now, then we go on to step 2. Step 2, that's this. But notice, over here, my cash price, I'm going to write that this is S0. That's my S0. And so, let's write and the quoted cash futures price is F0. So let's write that equation down. I'm going to use that equation. F0t is equal to S0 minus I e to the RT. Okay, so look what I want. I want cash futures price. I want to calculate this in the second step. So the left-hand side is what I want. That means I have to evaluate everything on the right-hand side. And the right-hand side, what is S0? I just calculated S0 on the previous step. That's 116.978. And what is I? I represents the present value of all the payments over the life of the contract. Okay, this is the life of the contract. That's why I put those two times in red. So that's the life of the contract. There's only one coupon payment over here, 6. And so I represents the present value of that payment. That is 6, discounted at what interest rate? 10. For what period of time? 122 days over 365. Because when I do present value calculations, 10 is the continuously compounded interest rate, so time has to be annual interest rate. So the time is measured in years. Okay, so 122 days is 122 over 365 of a year. Now, if I evaluate all of that, what do I get? It tells you that in the textbook, it's given by 119,711. That's step 2. The third thing is step 3. Okay, that's from here to here. So what I want is, now I know F0. I know the quoted futures price, and I want a cash futures price, and I want to calculate the quoted futures price. So let's write that equation down. Cash futures price is equal to the quoted futures price times the conversion factor plus the accrued interest. So let's fill in the blanks over here. First, cash futures price, that is this. That's that, which I calculated in the previous equation. So I can write that down. 119.711 The quoted futures price is what I want to solve for. The conversion factor is given by 1.6. And the accrued interest, you have to calculate the accrued interest at this point in time. That's the instant when the bond will be delivered. Okay, so the accrued interest over there is the number of days since the last payment, which is how many? 270 minus 122. That is 48, I believe. 148. That is 148 divided by the number of days between this. That is 305 minus 122. Right, that's 305 minus 122. Well, the textbook does it slightly differently. It says it's 148 plus 35. But I'm just calculating 305 minus 122 times 6. The textbook calculates this number as 148 plus 35. You should get the same number either way. Right? This is 148, 122 to 270, and 270 to 305. Okay? So, now, okay. So this is the equation, and what is the unknown I want to solve for? This. So, you leave Q, quoted futures price, on one side of the equation, bring everything else to the other side of the equation, and you solve that equation. It's a simple equation. You'll get 71.79. So, given the cheapest to deliver bond is the 12% coupon bond, given its quoted price is this, the arbitrage-free quoted futures price is that. So that's the arbitrage-free relationship between these two quantities, which we wanted. Okay? Okay, so let's pause for a second. I'll erase this board and we'll continue with the second part.